Systematic listing. Assume you are rolling 2 dice. The first one is red and the second is green. Use systematic listing to determine the number of ways you can roll a total less than 6 on the 2 die. First, we need to list all the different outcomes of rolling 2 dice. Now, they're telling us that the first dice is red and the second dice is green. That's just saying that the first die or the first number in our pair is going to be represented by the red die, and then the second number in our ordered pair is going to be represented by the green die. So red is always the first number and green is always the second number. Green can never be the first number, and red can never be the second number. So the way we're going to write this is we're going to write an ordered pair. And the first number in our ordered pair will be the first die. And if we look at a die, we have a cube with 6 sides on it. So each side represents a number 1 through 6. So if we look at the red die, we have 1, 2, 3, 4, 5, and 6. We have 6 choices to choose from. And then if we look at the green die, we also have 6 choices or 6 numbers that are being represented for each side of the dice. Now, when we roll our first die, we could get a 1 on the red die, and we also could get a 1 on the green die. So our first outcome could be 1, 1. And again, we're just writing this as ordered pairs. Now I'm going to do this systematically, keeping with 1 as my red die. So let's assume that we rolled a 1 on the red. I already listed 1 for green. So now I'm going to say I could get a 2 on green. Next, if I rolled a 1 for the red, I could get a 3 on green. And again, if I had a 1 on the red die, I could get a 4 on the green die. If I had a 1 on the red die, I could get a 5 on the green die. And then if I had a 1 on the red die, I could get a 6 on the green dice. So those are all my outcomes for rolling a 1 on the red die. Now I'm going to assume that I'll roll a 2 on the red die. So if I roll a 2, I could have a 1 on the green die, I could have a 2 on the green die, a 3, a 4, a 5, or a 6. Okay. So I'm just following this process, and remember, the first number always represents the number on the red die, and the second number always represents the number on the green die. I'm not flipping the positions of the red or the green die. I'll just continue this process. So I listed all the outcomes for rolling a 1 on the red die. I also listed all the outcomes for rolling a 2 on the red die, and now I'm going to list all the outcomes for rolling a 3. So I have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. And I'll continue this process until I listed all of my outcomes, which means I'm going to go until I roll a 6 on the red die. Okay, so I just listed all of my pairs for rolling 2 dice. These are all the outcomes that I could have, and there's 36 total outcomes. Now the question asks me to determine the number of ways that we can roll a total less than 6 on the 2 die. So in order to figure out the total of each dice, I'm just going to add the 2 numbers together. For instance, if I rolled a 1, 1, then the sum would be 1 plus 1, which would be 2. Again, if I rolled a 1, 2, then the sum would just be 1 plus 2, which is 3. So we can just continue this, adding all of the numbers together, and I'm going to identify the rolls that give me a total less than 6. So that means I either want a sum of 5, 4, 3, or 2. I just highlighted all of the pairs that give me a total less than 6. Now note that I didn't highlight any pairs that have a sum of 6 or greater. I'm only concerned with the pairs that add up to give me a total less than 6. Next, we'll just add the number of pairs that I highlighted. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 different pairs, so my answer is 10 ways. So that means there are 10 ways to roll a total less than 6. A designer has designed different tops, pants, and jackets to create outfits. How many different outfits can the models wear if she has designed the following pieces? 9 tops, 8 pants, 2 jackets. We're going to solve this problem just by visualizing a tree diagram. We're not going to draw or list anything. We can just visualize it, and that will help us get to our answer. So if we had 9 tops, then the first column of our tree diagram would be the 9 different tops. Then from there, we would draw 8 branches on each T for top. We would draw 8 branches to represent the 8 different pants. And then from the pants, we would draw 2 branches from there to represent the jackets. Now remember, the last column of our tree diagram represents all the different ways. So the number of branches that are in the last column is the number of different outfits for this problem. So if we look at this, we had 9 branches to begin with. Then we drew 8 branches for each T. So that means that was 9 times 8 branches. So that's a total of 72 branches. My third column will have 9 times 8 times 2 branches. So my answer to the complete problem is just found by multiplying 9 times 8 times 2. And I get a total of 144. So my answer is that there's a total of 144 different outfits.